Alright guys, so this video is going to be an introduction to groundwater. Alright guys, here are the objectives we're going to get into for this unit. Now, keep in mind before we hit these objectives that fresh water makes up a very small percentage of water on Earth. However, we need fresh water every day to survive. And 25% of all the fresh water we use on a daily basis is pulled out of the ground. And that's why we're talking about this stuff. It's really important for us in our daily lives, in addition to the formation of caves and everything else we're going to get to. But also keep in mind that fresh water, most of that's frozen. And beyond that, the next greatest amount of fresh water found on Earth is in the ground. So it's important for us to understand how it's accessible to people, how we get it. So in this unit, or in this video, we're going to cover saturated versus unsaturated. We'll talk about what groundwater is, talk about aquifers, zones of aquifers, and all those notes down there. Infiltration and recharge, aquiclude, got to talk about what a caprock is. So we're going to get into these things here, and keep in mind that you absolutely take good notes. It seems like there's a lot going on here, but some of these things we've already talked about. So let's go ahead and get into it. Hi. I have a glass here filled with some ginger ale, one of my favorite drinks, clean and refreshing. And I also have a paper towel. Paper towel is dry, and I'm going to go ahead and take that paper towel and I'm going to dunk it into the ginger ale here. And if you'll notice, look what's happening here. Water is dripping right out. I'm going to dip back in, and I'm going to pull it out. And water keeps on, or the ginger ale keeps on falling out of the paper towel. Why does it keep on falling out of the paper towel? Because it's saturated. And what that means is it can't hold any more fluid. This half of the paper towel, at least. It can't hold any more fluid. Now, the other half is still completely dry. The half that my hand is holding here, totally dry. That's the opposite. It's unsaturated. And what that means is there's more air in there than fluid. So again, here we have saturated, which means that it's completely filled with the fluid, and it won't hold anymore, which is why it keeps on falling out of there. And then we have unsaturated, which means that it has more air in there than fluid. Now, another word here, when we say something's unsaturated, we can also say that it's aerated, because it has more air in there than fluid. And that does it. Make sure you're taking notes. All right, groundwater. 25% of the water that we use here in the United States comes from underground. How does it get there? Rain, snowmelt, rivers, lakes, all that stuff where water can infiltrate into the ground causes groundwater to exist. But where does it exist? I think there's a misconception out there that water exists underground in the rocks. Like when water goes in, it kind of gets absorbed like a sponge into each individual rock. And that's actually wrong. That's not true. You know, to demonstrate this, here's this glass of popcorn that I have. And I'm sure you can see that between the popcorn, there's these little tiny spaces all over the place. And when I pour in some water here, the water is going in, but it's not going in the popcorn kernel itself. It's actually going in the spaces that are between the popcorn kernels. Those spaces are called void spaces or pore spaces, like the pores of your skin. And that's where the water is going. So water exists underground, not in the rocks themselves, but in between the individual grains of the rocks, or in between the individual rocks, or in between the strata. It exists in all the pore spaces between and within rocks, not getting absorbed into the actual rock itself. And that's what groundwater is. So what's an aquifer? Well, I gotta be honest, I don't think anybody can explain it any better than this guy, Bill, here. Let's take a listen.
What is a aquifer? What is a future? What is an aquifer? Anyway, aquifer coffee, aquifer tea, aquifer glass cells, the rain not falling, aquifer metaphor, underground stream, aquifer, weaver, aquifer, clean.
Well, I don't know about you, but I'm going to be humming that song for the rest of the day. If you want to listen to the rest of it, you can find it on YouTube. Just YouTube search "what is an aquifer" and it will come up as one of the first couple of links. But anyways, there's something that I really liked about what Bill said in there. He said an aquifer is an underground stream. I like that a lot. You know, groundwater is simply just water that's under the ground. And an aquifer is any sediment or body of rock that can hold and transmit water. And that's why Bill called an aquifer a river of water underneath the ground, because it is groundwater. Now, groundwater, again, is just kind of a general statement. It's a general term for any water that's under the ground. And what's different is that an aquifer is any sediment or body of rock that can transmit water or let it flow through. That's why he called it a river under the ground. Dug it. Nice job, Bill. I'm going to jump away from the objectives for a second and talk about something called capillary action. Even though it wasn't in the objective list, you still got to know what it is. Capillary, Capillary. And capillary action is important for us to understand because it helps us know how water moves underground as well within an aquifer. So make sure you get a couple notes on this section. All right, so here's a glass of colored milk, and here are some Milano cookies. And we're going to go ahead and put a Milano cookie into that colored milk. The milk is colored so it's easier to see. So there's the cookie, and if you'll notice, I'm going to stop it right here. You're going to notice, look at this milk. It's creeping right up the cookie as soon as it gets in there. Now keep on watching. Look at that colored milk ride right up that cookie. Now, how is that happening? It seems like the milk is defying gravity. It's going straight up there. That's called capillary action. Now, we don't need to understand the physics or the chemistry behind capillary action, but all we need to know is this. That capillary action is a pulling action that will pull a fluid up a substance, or will pull a fluid up against the force of gravity. And that's what capillary action is. Okay, so to help us understand groundwater a little bit more, I have this glass of Rice Krispies here. And we're going to let the Rice Krispies represent the ground. So we have the surface right here at the top, and then we have going into the ground, going to the bottom of the glass. And so let's go ahead and add some fluid into here. So we're going to infiltrate. There goes that word infiltrate again. Remember, infiltrate means for a fluid to go into the ground. I'm going to infiltrate some fluid in here. And, oh boy, everybody loves a snap, crackle, and pop. So notice what happened. The milk went into the ground, and we have two distinct layers. We have a zone of saturation, where everything down here is completely filled with the milk. And then we have a zone of aeration, or a zone that's not saturated. We learned about those words earlier. And this represents exactly how water exists under the ground. We have milk in between the pore spaces of the Rice Krispies, or in all the little holes of the Rice Krispies and in between. And then we have this dry portion up here. And then there's a boundary between. Now that boundary is called the water table. So far, if you haven't gotten it, we've talked about three things. We have the zone of saturation right down here, all this here, and that's where the ground is completely filled with water, or the cereal is completely filled with milk. We have the zone of aeration, which is where things are dry, and there's more air than fluid. And then we have the boundary between them, and that's called the water table. Now, if a house were to come and build in this area, and they would need some water, maybe they would build a well. So they build a well, and they suck out some of the water. Notice what happened. Our water table completely dropped. Our fluid went down because we pulled water out through our well. And all a well is a device that can pull fluid out of the ground. But the water table also completely dropped. Now, what would we need to do to fill this back up? Because if I kept on drinking, we would probably run out of milk pretty darn quickly. And a well can dry up as well. You can certainly dry up a well if you use it too much, but there's nothing else to go in there and recharge the well. Recharge, there's another vocab word. Recharge means to replenish or to put water back into the system. So maybe it rains. Maybe there's some snow melt. Maybe the ground is frozen like it is right now, and a whole bunch of snow melts, and it runs off into rivers, but then eventually, once that ground thaws out, that water can infiltrate into the ground, whatever it is. So we have some fluid that goes back into the system here, and we can recharge this whole aquifer. An aquifer, hey, there's a word for you. Again, a body of rock that can transmit fluid and that can transport and transmit fluid through the pore spaces. So again, as review, we have our zone of saturation, we have our zone of aeration. or we have the unsaturated zone. We're going to call it the zone of aeration. We have the boundary between them, and that's called the water table. We had infiltration, and that was milk or water going back into the system. Recharge, which was moving the water table back up to its stable state. And then use of the well, a device that is used to pump milk or pump water out of the system. Now, if we take a look at this, there's one more thing that we need to talk about. I'm not sure if you can see it. It's really tough to see. But there seems to be some water that's kind of, or some milk that's kind of pulling up the side of the glass. All these little fringes of milk that are going up the side of the glass. You can kind of see it in a few places here. And that's that capillary action. Right above the water table, there's something called a capillary fringe. And what that is that's where water is going against the flow of gravity, and it's actually creeping up into the zone of aeration. It's like a transition zone. It's not completely dry. It's not completely saturated. It's a little bit saturated, a little bit dry, and it's where that water is literally is creeping up. Why it exactly happens, you don't need to know about. However, the only detail we need to know about it is that it's that transition zone just above the water table into the zone of aeration. Make sure you got good notes there. We talked about aeration, saturation, water table, recharge, infiltration, capillary fringe. We talked about what a well was. A lot of stuff for you to get notes on. Make sure you make a diagram to help you out as well. Okay, so here, last demo, here we have our ground again, our Rice Krispies, and I'm going to infiltrate some fluid into the ground, and you'll notice something really quickly, that there's a separation here, that our fluid kind of stopped right here. Now, what that is we have this fluid that's not able to transmit down to the bottom here. It's all hanging out right over here, and that's called impermeable. There's this impermeable layer right here. I put a layer of plastic cellophane in there, some plastic wrap in there. So here's what we have. We have our groundwater, we have our zone of saturation, our zone of aeration, our water table, we have the capillary fringe, we had recharge or infiltration, and what we have here is we have this impermeable layer, and fluid can't transmit into there unless if we puncture through that impermeable layer. So we have our zone of saturation, zone of aeration, water table, impermeable layer here, and we have another aerated zone right down here. Alright guys, so in this video we talked about a lot of stuff. Saturated versus unsaturated, groundwater, aquifers, zones of aquifers and the parts that are in there, infiltration, recharge, we talked about impermeable. Now we didn't get to aquiclude, we'll talk about that in class. It's real simple if you want to write it down. An aquiclude is a layer that can hold water but it can't transmit it. So it would be a horrible place to put a well. Again, an aquiclude, a place that can hold water underground but it can't transmit it because the pore spaces are too tightly packed together. And then there's cap rock. I mentioned kind of indirectly what a cap rock was with that impermeable layer. It's just a layer that holds the water under the ground. A cap rock, it's an impermeable layer that holds the water under the ground so it doesn't flow out freely. But again, we didn't get into it. I'm going to define those in class just in case you didn't get it. Make sure you took really good notes on all that stuff above there. If you have any questions, always feel free to send me a message on Edmodo or go to my website, hit the contact button, send me an email that way. See you in class.